Hello everyone, this is Abita Sunkara and welcome back to our Enterprise Data Engineer interview series. Today's interview question is, what is a metadata-driven ETL framework? How do you design a reusable and dynamic ETL framework in enterprise projects? So this is one of the most common questions asked in interviews for senior data engineers, Azure data engineers, Databricks engineers, ETL developers, and data architects. So many developers know how to build ETL pipeline, but senior engineers are expected to design frameworks that can process hundreds of tables without writing separate codes for each table. So today I will explain how a metadata driven ETL framework works in a real enterprise projects. So let's imagine we are working for a large multinational bank. So the bank has more than 250 source tables spread across core banking, CRM, loan systems, payment gateways, card management, and external APIs. So every day new tables are added, existing tables change, and business rules evolve. So now imagine build a separate ETL pipeline for every table. For 250 tables, we need to add 250 pipelines. So each pipeline would contain similar logic for extracting data, validating it, transforming it, loading it, auditing it, and handling errors. So maintain hundreds of pipelines becomes extremely difficult. So whenever a new column is added or a business rule changes, developers must manually modify multiple pipelines. So this increases development time, introduces bugs, and makes onboarding new tables very slow. So the business asks us to design one reusable ETL framework that can process every table without writing new code each time. So instead of hard coding source names, target tables, mappings, or validation rules, we store all these details in metadata tables. So that ETL framework reads this metadata and dynamically builds the pipeline. So this makes the solution scalable, reusable, and much easier to maintain. Then now let's see how this architecture works. So everything starts with multiple source systems such as core banking, CRM, loans, payment systems, APIs, and flat files. So instead of embedding configuration inside the ETL code, we maintain centralized metadata tables. For example, one table stores source configuration including connection strings and source table names. Another table stores target configuration defining where the data should be loaded. So a column mapping table tells the framework how source columns map to target columns. So a watermark configuration table stores incremental load information. Then validation rules define mandatory fields, duplicate checks, and business validations. Then schedule configuration controls when each pipeline should run. Then now comes the framework controller. Its responsibility is to read metadata and decide what needs to be processed. It passes all this information to the dynamic ETL engine. So the ETL engine automatically generates SQL queries, extract data, perform transformations, validate records, and loads them into a data warehouse. So every execution writes detailed audit logs containing row counts, execution time, errors, and pipeline status. So this architecture allows one framework to process hundreds of tables without changing the ETL code. Then let's follow the life cycle of one table through the metadata driven framework. So the scheduler triggers the framework. Then the first step is reading the metadata tables. After that, the framework identifies which source tables are active and scheduled for processing. So it also retrieves the load type, whether it's full load, incremental load or CDC. Next it reads the column mapping table. Then using these mappings, the framework dynamically generates SQL statements. So no SQL is hard coded here. So if a new table is added, we only update the metadata. So the framework then loads data into the staging area. So data quality checks are executed based on validation rules stored in metadata. Then valid records are loaded into the data warehouse. Then rejected records are written into error tables. Next, the framework captures audit logs including start time, end time, total rows, successful rows, failed rows, and execution status. Finally, it updates the watermark table. So the next execution process only new or changed records. The same framework repeats the entire process for every configuration table. So that's why metadata-driven ETL is considered one of the most scalable enterprise ETL design patterns. So now this slide covers the practices we follow in production. So first, metadata should always be clean, standardized and version controlled. Never hardcode table names, SQL queries or business rules inside the ETL logic. Then store everything in metadata. Then use separate control tables for source configuration, target configuration, column mapping, watermark configuration, validation rules, scheduling and error handling. Then implement dynamic SQL carefully and always validate metadata before execution. Then support restart capability. If a pipeline falls halfway, the framework should restart from the failed step instead of processing everything again. Then maintain detailed audit logs for every execution. Then track row counts, then execution duration, failures, warnings and data quality scores. So implement automated alerts through email or Microsoft Teams whenever failures occur. So another important best practice is governance. Assign ownership for every metadata table. Then track changes using version control and review metadata changes before promoting them into production. Some common mistakes include hard coding SQL queries, creating separate pipelines for each table, ignoring audit logging, missing restart mechanisms, and poor metadata validation. So avoiding these mistakes significantly improves scalability, maintainability and operational efficiency. Now we are in interview section. So when an interviewer asks what is a metadata driven ETL framework and why do organizations use it? So this is how we have to answer. A metadata-driven ETL framework is a design approach where configuration tables control ETL execution instead of hard-coded logic. Then metadata defines source systems, target tables, column mappings, validation rules, load types, scheduling and watermarks. The ETL framework reads this metadata, dynamically generates SQL, extracts data, performs validations, loads the target systems, captures audit logs and updates watermarks. So this allows the same framework to process hundreds of tables without creating separate pipelines. Then compared to traditional ETL, metadata-driven ETL provides better scalability, easier maintenance, faster onboarding of new tables, then standardized processing, improved governance and lower development costs. So in my project, we typically maintain source configuration, target configuration, column mapping, watermark, validation, scheduling and error configuration tables. So using SQL Server, Azure Data Factory, Databricks, Snowflake and Power BI, we had to build reusable frameworks that support full load, incremental load, CDC, restart capability, audit logging, and automated monitoring. So, this architecture significantly reduces maintenance effort while improving consistency and reliability across enterprise data pipelines. So, here are a few lessons from real production projects. Never hardcode table names or mappings in ETL pipelines. Keep business rules inside metadata so they can change without code modifications. Design your framework to support full load, incremental load, and CDC from day one. Then always implement audit logging, restart capability, and watermark management. Then build one reusable framework that can process hundreds of tables rather than creating individual pipelines. So that brings us to the end of today's episode on metadata-driven ETL framework. Here the biggest takeaway point is a metadata-driven ETL framework replaces hard-coded logic with configuration tables, allowing one reusable framework to dynamically process hundreds of pipelines while improving scalability, maintainability, governance, and operational efficiency. If you found this video helpful, please like, share, and subscribe to the channel. Don't forget to press the notification bell so you never miss the next episode in our Enterprise Data Engineer interview series. Thanks for watching, and I will see you in the next episode, Enterprise Audit Logging and ETL Monitoring Framework. Thank you.